All right. So we determined that the counselors probably aren't telling the whole truth here because of only a 4% chance, which means it's kind of unlikely for them to have gotten this difference just by chance alone. All right. When it comes to random samples of two groups in a randomized experiment, the statistic p hat of 1 minus p hat of 2 is our best guess for the value of p1 minus p2. We can use a familiar formula to calculate the confidence interval. So we take the statistic minus the critical, or plus or minus critical value times the standard deviation of the statistic. Okay, so this is the standard deviation of the statistic, remember, and you can look on your green sheet and it has it written there. This is written on your green sheet. This is written on your green sheet. They tell you that the statistic for this is going to be p hat of 1 minus p hat of 2. They tell you this is the standard deviation of the statistic, and we all should find a critical value by now. You have everything you need to know in order to do this right here. Actually, I shouldn't even have to show you how it's done because you should be proficient at taking a formula and plugging it in and then putting in the right values. But I am going to go through it with you. So because we don't know the parameters of P1 and P2 when we're trying to find a confidence interval, because remember, a confidence interval is so that we can conclude something about an unknown population. So when we don't have it, they do allow us to put the p hat of 1 and p hat of 2 in the formula in order to find it. And remember, the results is called the standard error. Remember, that's where something you all kind of got confused is that when I started calling this standard error. This right here is standard error because I put p hat in the formula instead of p. And when that happens, this standard deviation of the statistic then becomes the standard error, and then we call it of proportions or of the means. Okay, that is not the same as margin of error. Hear me on that. It is not the same. Okay, it's just the standard deviation of the statistic, and all you did was put p hat in there, so it became the standard error. So if the normal conditions are met and we find our critical z for the confidence interval level, the standard normal curve, our confidence interval for P1 minus P2 is as follows. Look, this is the statistic. So the statistic is this right here. When you subtract them, p hat of 1 minus p hat of 2. You get the critical value from your chart, and the standard deviation of the statistic part is right here. What I told you on the top of your chart to call the standard error as well, and that's because we put it in there. So you have every part you need to plug in to get this formula. Now you just go back and pull out p hat of 1 from your problem and stick it in where it goes, and then p hat of 2 from your problem and stick it in where it goes. And depending on what the confidence level they said, you'll get your critical value off of your sheet. Okay, two-sample interval for a difference between proportions. And they tell you, remember, you have to be random, you have to be normal, and they have to be independent. Notice that both count, both, again. So all you're doing in the plan step is now checking for the other population distribution as well for both the normal and the independent. And you have to check it to be random as well. So you're double checking the conditions, one for one group and one for the other group. All right. Example, teens and adults on social networks. As part of the Pew Internet and American Life Project, researchers conducted 2 surveys in late 2009. The first survey asked a random sample of 800 U.S. teens about their use of social media and the Internet. A second survey posed similar questions on a random sample of 2,253 U.S. adults. In these sample studies, 73% of teens and 47% of adults said they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the two U.S. teens and adults' social networking sites. All right, so a couple of things I'm going to write down from this problem before we do it is that, look at the problem here. We have, they asked 800 U.S. teens, so we're going to call, I'm going to call group 1, I'm going to put teens underneath here. Why? Because I'm going to keep it straight. And then my group 2, I'm going to do adults. I'm going to keep it straight. So for each of these, I have to have the number and the sample. So right now for N1, I have 800. For N2, which is my adult group, I have 2,253. All right? N1. And so then you also need to know your P hat. So your P hat of 1. In these studies, the teens are 73, so 0.73. And for the adults, so this is P hat of 1 equals, and then I have P hat of group 2, it's going to be equal to 0.47. And they want a 95% confidence level. Okay, so on your green sheet, you would find that the Z critical for that is 1.96. So we now have everything we need, and I organized it so that I can do this whole state plan do conclude thing. So you're going to state that you're going to find, construct and interpret a 95% confidence interval for the difference of proportions of all U.S. adults who use social networking sites. This is what we're going to do. We are going to construct and interpret. This is my state plan part. So you would just restate that. The plan is where you're going to check your conditions. Random, normal, and independent. I'm not going to go through it because you should be able to do it. I'm worried about the do step. So here in the do step, this is when you take the P hat of 1 minus the P hat of 2. That's your statistic. Plus or minus the critical value. Remember, I'm getting this off the green sheet. Times the square root of I believe from your green sheet, let's look at it real quick. It's right here. All right, all under one square root. So we get one huge square root. And I'm going to get P hat of 1 times, technically it's 1 minus P hat of 1, over N1, plus P hat of 2 times 1 minus P hat of 2, all over N2. So this is my formula. So now I can start plugging things in. Remember that this is 0.73 minus 0.47, plus or minus, my Z critical is 1.96, times the square root of 0.73 times 0.27 over 800 plus 0.47 times 0.53 over 2,253. All right, so now I've shown my work of what I'm doing here. All right, so I can punch it in the calculator and get my values, or I can run this test from beginning to end in your calculator. I'm not going to show you how to do that because by this point you should be able proficient to figure it out if you really want to do it. And it'll give you results. But this is how you're setting it up. All right, so you're going to subtract these two and get a value plus or minus this times this. All right, and then you're going to add it and subtract it, and you're going to get a confidence interval, and then you're going to interpret it just like we did before, but now it's on the difference, so the true difference, so the population difference in proportions. So you're going to have this, but you're going to restate what you did in the state part anyways. Okay? Let's go ahead and show you this. So they state it. Plan, random, here's your normal, they're checking it for both. Independent, they checked it for both. All right, so here's the do part. They set it up just like I did. 0.26 plus or minus. This right here, this whole thing came down to 0.037. They added and subtracted to it, and here's their interval. Now they're concluded. We are 95% confident that the interval from blank to blank captures, and I said the only difference is going to be that the true difference in proportions, because we're doing it on the difference, of U.S. teens and adults using social network sites. All right? This interval suggests that more teens than adults in the United States engage in social networking by between 22.3 and 29.7 percentage points. All right, so that's what that's telling you, is that if we get a positive interval, okay, then they differed. Okay, they're not going to differ if our interval contains 0, but we'll look at. Okay, so these are your videos for now, and then we'll do hypothesized testing later.